Hello everyone, this is Cameron Snow with Danomics. In this video, I'm going to be covering our flow tools, and I'm going to go through a lot of examples, as well as covering the basics with flows so you can construct your own flows outside of the ones that I'm showing in this video. So I know a lot of you have been using flows opportunistically within your day-to-day use of Danomics, but I wanted to kind of go in and provide some background as well as some examples on this. So for those of you who aren't using flows, you're probably wondering what are flows within Danomics, and what they are collections of small tools that operate essentially in a sequence to perform a set of tasks and to do that consistently. And when we designed the flow system, we really designed it with a few different use cases in mind. So things like performing repetitive tasks. You could set up a flow once and then run it over and over, so you don't have to use as many button clicks. Running batch operations, where you're going to operate on each piece of data in a consistent fashion across a data set. Also for flows, a lot of the specialty operations within the software have been designed to run in flows. And then finally, when you're executing your own custom code, specifically Python code, that can also be ran in the flows system. So when it comes to using flows, one of the most common questions I get is, when should I use flows? And really there's two natural times for this. You can either use flows before you start your interpretation or after you complete your interpretation. And there's different flows that you would run at each step in this chain. So let's go into a few of those. So when we start off with flows before the interpretation, some of the examples that come to mind would be using things like our log health check tool to try to detect any structural problems with your data, running the Mnemonics Analysis tool to make sure that your alias tables are capturing all of your mnemonics fully, performing things like log unit conversions, or trimming the flat spots off the top and base of your logs. Those are all examples of flows that I would run before starting an interpretation. And then after the interpretation, some of the example operations that I might run would be writing specific interpreted curves to a log database, exporting the petrophysical results as a set of points, or generating grids from the petrophysics results. So a lot of the flows that you'll be running after you perform your interpretation are really about moving your interpretation from the CPI file to a different format, whether or not those are points or grids that you're going to use in a dot map, or perhaps exporting logs if you're going to write stuff back to a corporate database or something like that. When you think about repetitive and batch operations, I just wanted to maybe make that a bit more clear. The idea is that with flows, you build once and then run repeatedly. So some examples like this. Let's say you wanted to generate a set of grids based on your petrophysical interpretations, and maybe you're always generating the same set. Let's say average clay volume, average total porosity, effective porosity, saturation, net reservoir, net pay, etc. You could go in and set up a flow to perform that, and then you go in, you work on your petrophysics project. You want to then generate that same set of grids for the same set of zones. You can just go in and hit the run button, and your flow will execute on that and generate you that set. So that's the type of operation where maybe it takes you a little bit of extra time to set that up, but then on the flip side, it saves you a lot of time as you start doing it more and more often. Another example of kind of a repetitive or batch operation is your log cleanup practices. So let's say you wanted to go in and run the tools to fix any problems with log depth steps, trim flat spots off the top and base of logs, perform unit conversions, splice your logs, etc. So that you're probably going to want to do about the same thing on every data set. So you could set that up, and the only thing you would then have to change to run that would be the log input and the log output portions of it. So you basically just tell it, which data set to run it on and what name to output it as, and you'd be able to do that with one button click. Another example would be things like renaming curves before you export those to a corporate database. So I know a lot of you have very specific naming conventions, and a lot of times those don't line up with the defaults that come out of Danomics. Well, in this case, you could go in and rename curves, curve by curve to make sure that you get exactly the naming nomenclatures that you're looking for. So that'd be another example of a batch operation that you do repetitively within Danomics. And then for specialty operations, so we do have some very specialized tools. For example, the multi-well Facies models, deviation survey calculation, saturation height modeling, and that's really one of the strengths of Flows. Is sometimes these types of tools don't fit cleanly into either petrophysics or mapping or the decline curve analysis. So, this type of a flow tool, gives you the ability to do specialized one-off operations. And for us, these are tools that are easier for us to build out because they don't affect the core part of the product. It's just one specific tool, so we can have a much faster development cycle on those, which allows us to meet your needs a bit better there. And then finally, when you want to run custom code, we let you execute your own Python code on top of Danomics data handling capabilities. And these Python tools can have a very wide range of applications. You can use them to manipulate well log data, calculate petrophysical properties, even execute machine learning models. In these Python tools, we've put a lot of effort into these to really help you unlock the innovations within your company. So you can do things like share out your Python flow tools, and even build out a user interface on those. So that way, if you have a power user that is writing out the Python code, they can then share that with users that don't want to have to deal with the code, but still want to have access to that tool's capabilities. So when it comes to how you should think about flow tools within Danomics, it's useful to break your problem down and ask yourself questions at each step. So the 4 questions I like to ask myself when I'm putting together a flow are: what are the output that I want from the flow? What data do I need to operate on? Do I need to access my interpretations? And does the data need to be transformed along the way? So let's go through that with an example. So let's say that I wanted to grid a property. So let's say I've performed my petrophysical interpretation and I want to make a map grid of my average clay volume over each zone. So, what are those questions, and let's go through those. So what's the output that I want from the flow? I want to make a grid file for my average V clay property. Okay, what data am I operating on? Well, this result is based on the well log. So I start with my well log. So for example, my gamma ray and my neutron density. I'm going to perform some petrophysical calculation, and then I'm going to transform the data. So, but it all starts on well logs. And then, as I said, this is a calculated property. So do I need to access my interpretations? Yes. So we need to access our clay volume curve. And does the data need to be transformed along the way? Yes, we start with logs, and from those logs we calculate a V clay curve, and then we calculate an average clay volume, which is essentially a point associated with each zone, and then we'll convert those points to grids that we'll then use to make that map. So let's continue along with this example. So it's important to think in small increments as you're going along and doing this. And so to perform this operation, this is kind of the chain of tools that you would need within a flow to execute on it. So you would start with a log input, and in that log input, it's bringing our log data into the flow so we can work with it. Then we put what's called a CPI log calc tool into the flow, and this is what allows us to bring our interpretation into the flow. So it tells it which CPI file, the tops and the well headers that we should use. And it's also where we'll tell it that we specifically want our average clay volume. So that's what we are putting here in the config equations, and then here is that information on the CPI file, tops and well headers. We'll then move into a optional point select, and in this case, maybe we're telling it what zone we want to grid it for. If we only want to make it for one specific zone, that's optional. Otherwise, we will make this for each and every zone. So if that's what you want, that's great. But if you only want to make it for one zone, this is where you would narrow that down. Okay, we then need to convert our points to a grid, and so we use the points to grid step, and this is also where we'll tell it the gridding algorithm that we'd like to use. And then once we've created that grid, we need to output that grid and give it a name, and that's where we have our first grid output block. Now I wanted to see, I wanted to smooth this grid and generate a smooth copy. So in this case, I've added a grid smooth block and a second grid output block. You could have stopped after the first one if you would like, or you could have omitted writing out that unsmooth grid. So within a flow, you can have multiple outputs along the way, and that's often useful for looking at the effects of subsequent flow tools. So maybe you want to start by even outputting your points, so you're able to see those. You have your point select, so you're able to see what's filtered. Then your first grid output, the smoothing process, and your second grid output. So, but it's useful to think about these in small increments. And I think when you're going through flows, if you think about each particular step of your interpretation, it will help you figure out how to build these flow tools. So what's the input? What's the calculation or transformation we want to do? Do we need to apply filtering? What's the output that we need to perform? Okay, so now I want to go into some specific examples, and associated with each of these examples is another video where I actually go through building out that specific tool step by step, whereas here I'm going to just cover it in a high level. So make sure to check out each of the related videos. So starting off, the log health check tool, this is something that you should probably run on all of your data sets before you start your interpretation. This tool basically analyzes our data for structural problems. It runs 15 basic checks on our data, and then it prints out a summary job report that's visible in the jobs log. So it'll check for things like, do you have repeated tops or tails on your logs? Do you have data gaps within your well logs? Do you have consistent depth steps? Does that match the information that's in the LES header, etc.? So running this tool can help you identify problems that may affect your subsequent interpretation. The Mnemonics Analysis tool, this is useful in that it helps you evaluate if your alias table is able to capture all of the common curve names that are in your log data set. And what it does is it provides a summary of essentially what aliases are available and how many of them are in each are in your project, but it'll also go through and give you a listing of all of your mnemonics so you can see what's missing. Now keep in mind, you're probably not going to capture 100% of the aliases with the default alias table, and that's because some things we just don't alias by default because they're curves that either aren't used in the interpretation or that are quite rare. And second, your company may have some specialized mnemonics, in which case, of course, we're not going to have those in our default alias table, so you can go through and add those. This is a good way to evaluate those, and once again, something that I would encourage you to run on every data set before you start your interpretation. Okay, so one of the things you may have seen in your logs is a lot of times you'll have what we colloquially refer to as flat spots at both the top and the base of your logs, and this generally happens either due to the tool sitting at the bottom of the hole, and as they are pulling it up, the tool's not actually logging to interval. It's just that they're winding up cable before they actually start pulling the tool up. So a lot of times we'll see these repeated samples, especially at the base of logs. Sometimes you'll see them at the top of logs as well. So to address this problem, we input our logs, then we use a tool called null repeated log samples, and this will operate at the alias level. So you'll go through and trim the flat spots off either the top, base, or both, or throughout the entire log. And you'll do this for each relevant alias that you want to operate on. And it's worth noting that you can stack many of these on top. So for example, here you can see I've got several null repeated log sample tools stacked on top of one another. And this is because I'm operating on gamma ray, resistivity, neutron, density, my MV, DV curves, etc. So for each of my aliases where I think repeated log samples are an issue, I'll have one of these tools. And then here in this, I've also got a remove all null logs, so we can get rid of logs where all the values are null. And then I've outputted that log database, and then that's what I'll use within my CPI file. So this is a tool that's designed to clean up that data before it gets pulled into the CPI file. And this is important to do because it will affect how either subsequent splicing or log merging is performed as well. If you are working with deviated wells, you're probably going to want to process your deviation surveys so they can be used within the CPI file. This is a bit of a specialty tool, something you'll probably have to run once per project. But essentially, what you do is you just tell the tool what your measured depth, inclination, and azimuth are for your points data set, and then it will calculate your dx, your dy, and your TVD at each step. And it also will rename your columns to ensure that the column names are correct for use in the CPI and other tools. Okay, so now let's say you've done your interpretation and now you're ready to run some flows to get data out. So let's take a look at a few examples here. So you may want to use it to export a specific list of curves. As you know, in the CPI file, we have a default list of curves that we export. You have to go through and select those every time you do an export. You could set up a flow to have those, and this would prevent you from needing to reselect those specific curves that you want each and every time. Where all you would then need to go in and do is make sure that you've got the right CPI file, tops, and well headers available. So that's an example of how you would export a list of curves to a log database, which you could then just right click on and download. Likewise, you can do the same for when you're generating grids or points. So in this example, I've gone through in the CPI log calc tool, and I've added a large number of these summaries, so average properties and some summations. uh, where we'll go through and we'll write out a points data set. Uh, we may do some optional filtering, and then I'm going to turn those into grids for each and every one of my zones. So this is a way you can get out a consistent list of map properties without having to go in and designate which ones you want in the CPI config. Okay, I know I've said that you'll predominantly use flows either before or after your interpretation. There are some times when you may use a flow during the interpretation, and predominantly the use case for that would be to generate well lists. So let's say, for example, you only wanted to work on the wells that are going to affect, calculations such as porosity or hydrocarbon pore volume. You could use flows to get out a list of those wells. So to do this, to generate a well list, essentially we'll go through and we'll use our CPI file to do this. So we'll start with our log input, where we'll bring the log data into the flow. Then we'll use a CPI log calc, where we will select a property. So maybe we select a property like our hydrocarbon pore volume. And then we'll do a point select where we can filter by zone. Another point select where we can say, all right, let's only work on this property if it is not null. And then we'll output points. And this points output will have a list of APIs. And that list of APIs can then be used as a designated set of logs to use in your petrophysical interpretation. So this is an example of where maybe you've done a little bit of interpretation, you want to narrow down your well set, and then we use the information within flows to restrict the wells that we're going to be working on via a well list. So that's an example of when you would use a flow during your interpretation. And then some of our specialty operations that you'll find in flows. So for example, multi-well facies models within the facies interpretation within the petrophysical interpretation file. You'll have the option to make a key well model or to use a file model. And the file models are generally multi-well models where you're pulling data from many wells. And in this case, to do this, we would select our log input to bring log data into the flow, our CPI log calc, so we could generate properties that are such as our gamma ray final, our neutron, our density, etc. And remember, those final curves are ones where we've already applied normalization, bad hole ID and repair, things like that. So that's why we're pulling those in through the CPI log calc. We'll then choose which of those curves to use within our facies fit model, and then we'll output a specially formatted points file out of that, which is then what we'll bring into our petrophysical interpretation to apply that multi-well facies model. So that's an example of a specialty tool. And then finally, we have our Python-based flows. And these can be as simple or complex as you would like them to be. You have the full power of Python here. You can import third-party libraries. So there is a lot you can do with Python-based flows. And essentially the idea here is that you're using the Danomics infrastructure to bring data into and out of Python, which when you're doing things like deploying models is often one of the more tedious tasks here. So we're handling all that for you in the background, and we give you a consistent set of APIs for accessing things like curve data, well header data, points, etc. So you can then operate on that as needed. We've also put in the ability to add user interfaces to your code and to share this with others in your company as a standalone flow tool. We are actually going to be doing a separate webinar for performing Python-based flows, and the reason why there's you know, such diversity in the type of operations that you're able to execute on, we think that merits a longer video specifically for that topic. Okay, so that is kind of the current state of flows. The real question now is what's the future of flows? Well, you know, we see a few different areas there. Specifically, you know, we're going to add more specialty tools. There are a lot of things on the menu here, such as you know, landing zone analysis tools, deviation health checks, log statistics and analytics. So we're going to give you more ways to generate more data. So that's one area that we're looking at putting some development effort into. Another are additional convenience tools. So tools for combining, merging, and appending data sets within flows. One thing we were considering is the ability to perform branched flows. So this would be, say, if the data looks like this, you know, perform this operation, otherwise do this other set of operations on it. So those are branched flows. And then also potentially interactive flows where you would start an operation and, you know, if certain criteria are met, then you may interactively perform some type of manual operation based on you know what's happening. And then of course there will be enhancements to the existing tools. So you know there will be more output modes. So some things right now we only write to the job log. We may add additional points outputs there. We think that we're going to add a lot of additional checks and QC options to things like the log health check tool or the Mnemonics tool. And then there will probably be some additional input-output options. So right now, out of the box, you have access to points, tops, logs, and production. We will probably add support for things like well header files, you know, maybe some additional file types, you know, files that aren't directly used within Danomics itself, things like, you know, zip files, text files, etc. So be some options there that are available out of the box as well. So that's it for this webinar. Now remember, for each of those example flows that I showed you, there is an associated video that has been made for those. So make sure to go through and look at those if you're interested. And in each of those, I'll go through each flow tool step by step and explain why we're adding that flow tool and why we're specifically adding each parameter and setting it that way to try and give you a more granular understanding of how these work. And so those will both be in the link to this video on YouTube and on our webinars and help pages. And remember, if you have any questions, you can always reach us at support@danomics.com. Thank you.